Now let's look at multiplying rational expressions. And first I want to look at multiplying fractions and use the method that we will use for multiplying rational expressions for multiplying these fractions. I think you all recognize that when we multiply fractions, you multiply the numerators and you also multiply the denominators. If we multiply these, you see you get 5 times 3 is 15, 6 times 25 is 150. So we get 50 over 150, and this one is fairly easy to reduce. I think you can see it reduced to, if both have 15 as a factor in common, reduced to 1/10. But let's use the method that we're going to use with rational expressions, and that is instead of multiplying out like that, we'll actually find prime factors of all the numbers involved, all the numerators and all the denominators, put it together as one fraction, simplify it after we do that. So if we take 5, 6, we can write it as 5, and then 6, putting it in prime factors, would be 2 times 3. Take 3/25, so we have 3 in the numerator, and prime factors denominator 5 times 5. You can put it together as one fraction, or we could do it simply in the way it is now. But putting it together, we have 5 times 3 in the numerator. Denominator, we have 2 times 3 times 5 times 5. Okay, now as we did earlier in simplifying fractions, we can divide out common factors. It looks like 3 is a common factor as well as 5. Remember, these all always have 1 as a factor, and it's still there. So if you totally divide out a numerator denominator, there's still you need to remember you still have to put the 1 there. So what we're left with on top is 1. On the bottom we have a 2 and a 5. 2 times 5, which is equal to 1/10. So again, this is a method where you find factors and then divide those out to find what it simplifies to in the end. Let's try it with two rational expressions that we want to multiply. The first rational expression is x plus 3 over x squared minus 4. The second one is x squared minus x minus 6 over x squared plus 6x plus 9. Similar to what we did up here with fractions, let's factor all these polynomials in either the numerator or denominator, and then see if there's some factors that we can cancel out. So let's start with this fraction. We have x plus 3 that we cannot factor that's prime, but x squared minus 4, that's the difference of two squares, that will factor as x plus 2 and x minus 2. Okay, so this is the same fraction as that, just we wrote it in factored form. Let's take this rational expression and try to factor the numerator. The numerator is a trinomial, so let's try to factor it as two binomials. And it looks like we have an x and an x, and I can see that plus 2 minus 3 should work, factoring that, because 2 times negative 3 is negative 6. If you add those two, 2 plus negative 3 is negative 1, so that will work. And here we have another trinomial. Let's factor that into two binomials. We'll have an x and an x, and it looks to me like a plus 3 and a plus 3, because 3 times 3 is 9, 3 plus 3 is 6. We could put these into one fraction now, but you really don't need to. You need to realize that this is grouped together as a factor, and let's see what we have in common. I like to start right here on the left and then look on the bottom, left to right, so I don't miss anything. There is an x plus 3 on the bottom, so we can divide those out. Now let's come here. X plus 2, there's x plus 2 on the top. There is one on the bottom. We can divide those out. And then the last factor on top is x minus 3, and there does not appear to be an x minus 3 on the bottom, so that's as far as we can go. Now all we need to do is put this together into one fraction. All we're left with on top is the x minus 3. On the bottom we have x minus 2 as a factor, and also x plus 3. At this point, for me, you could multiply these two binomials back out and get a trinomial but normally it'd be fine to leave it in factored form like that.